How rich are the top 1%? So we're going to be exploring something called the Lorenz curve today to help us understand some basic stuff. In 2012, the New York Times claimed that the wealthiest 1% of the people in the country received just under a fifth of the country's pre-tax income. So 1% receives just under 20% of the income. Today we're going to explore how calculus can help us understand this income and wealth inequality. So the Lorenz curve gives the proportion of the total income earned by the lowest proportion X of the population. For example, L of 0.90 would be equals 0.55 would mean that the poorest 90% earn 55% of the total income. Interpret L of 0.25. So again, this is our example. This means the poorest 90% earn 55% of the income. So this will be the poorest 25% earn 10% of the total income. If everyone earned exactly the same amount of money, so if there was no wealth inequality and everyone was earning the exact same money, L of 0.3 would equal 0.3. And L of 0.65 would be 0.65. 30% would earn 30% of the income, 65% would earn 65% of the income. Makes sense. The curve y equals x represents total income equality. Again, equality. The Lorenz function for a particular company is given by this expression. L of x equals 0.25 plus 0.75, those two percents add up to 100, x to the 11th. What does the area between these functions, region A, tell you about the country's wealth distribution? So let's move this up and take a look at this picture. So we have the curve y equals x, and then this is L of x in this particular equation. So this is y equals x, and this one down here is L of x. Okay. What does the area between these functions, region A, tell you about a country's wealth distribution? Think about that for just a minute. So this is the area between this percentage poorest earn, so on and so forth. Okay, so what's the area between these represent? The bigger the area, the greater. So the more area we have, the greater what? What does this represent? This is the greater wealth inequality. That should be an L right there. Okay. So the bigger the area of A, the greater the distance is between inequality. This is total equality. And L of x is here. So the bigger this area gets, the more disparate the income is. Give a too high and a too low estimate. So too high, well, that would be all the area. And so the area under this, since it goes from 1 to 1, would be half. So too high is 1/2, or 0.5. Too low. 10. I don't know. I guess, yeah, let's pretend it was just this area here. So 10. Really small. To approximate the area of region A, split the region into 10 rectangles, like this blue one that's been drawn on the picture. What is the width of each rectangle? The width of each rectangle will be 0.1, or 10%. Find the height of each rectangle shown. Interpret your answer. So the width of the rectangle is 0.1, which, by the way, if you wonder where I got that, 1 minus 0 over 10, or delta x divided by 10, because there were 10 rectangles we were trying to get, and we had 1 minus 0, 10 rectangles. Okay. Height of the rectangle shown. So how high is this? Well, normally it's just the curve, right? How high it is on the curve, but we've got these two curves. And so the max height is x, but then we have to take this part off. So I think it's x minus L of x. And so the rectangle shown here, I guess they're talking about this particular rectangle, the height will be 0.7 minus L of 7, L of 0.7, and then my calculator is going to find that for me. So this is my Lorentz equality. So I'm going to have 0.25 plus 0.75 times x, in this case 0.7, raised to the 11th power, 2.862 becomes 0.7 minus L of 7, which is 0.2648. And so this is equal to 0.435142. There you go. Let's interpret. In this country that we are talking about, there is 43.5, just changing this to a percentage, gap between what that's my new word, what the poorest 70% earn and what they would earn with perfect equality. All right. Write an integral expression that would give the area of A using infinitely many rectangles. So the integral from 0 to 1 will be the height of each rectangle. And so that's the height of the rectangles. And the width of each rectangle will be dx. Okay. The Gini coefficient is a measure of relative inequality of income. It is equal to A over A plus B, by the Gini coefficient for this country. So A, the area, that's A. Let me get back up. That's A. Let's figure out what A is. Math 9, 0 to 1 of x minus L of x, which is this equation right there. 0.25 plus 0.75 x raised to the 11. Close that parenthesis, and then my parenthesis for my integral, and then dx. So there's A. Remember this capital A. It's right there. Okay. So A equals 0.1875. Now here's the part that's a little tricky. A plus B is this whole area. And so in this case it is half. Which is why we were back here to go, hey, too high. It's our too high. That's this area plus that area, which is 0.5. And so the Gini coefficient is equal to 0.1875 divided by 0.5, which is equal to 0.375. What does a high Gini coefficient indicate about the country? What does a low Gini coefficient indicate? Well, since A plus B, I think is always going to be 0.5 because you're always going to have x and then the curve. And so since the numerator is A, and so the numerator is larger, the larger the numerator, the denominator is going to stay constant. Because the bigger A is, the poorer the country is. The larger, not the poorer the country, the greater the inequality of income is. So the bigger A, the greater the income inequality is. And I think that that should stay here because this isn't going to, that's going to be the same. So I'm going to go with high GC equals high inequality. And low GC is low inequality. So I guess the biggest this can be is 1. Because if you have 0.5 over 0.5 equal inequality, oh, because A would be 0. Got it. Okay. My brain is a little bit tired this morning. Okay, this afternoon. All right, let's take a look at this. So topic 8.3, 8.4, and 8.6. So we're doing 3 topics today in this, and there's a lot going on here. So we'll be practicing this a lot, and we'll have some breaks in between this and, you know, practice, etc., etc. We'll have some days to get this kind of down. So the area between F and G on a closed interval from A to B, when F is greater than G, so when F is the biggest function, is given by A equals the integral from A to B of the upper curve minus the lower curve dx. Okay, so we subtract to find the difference. The region must be bounded. Therefore, we have to have a closed interval. We have to start and stop. And the graphs kind of bound themselves. I'll explain that in a little while. I mean, sometimes we leave it where they don't actually intersect, but the idea is that they intersect, that the two curves intersect each other. The area between F and G, they're intersecting each other. Area is always positive. We never have negative area here. Sometimes the upper and lower functions switch places, and it's harder to tell on this one. I tried, but G is the equation that starts up here, comes down, up, and then keeps going down. F is this one. F is the one that's on top at the beginning, but in the bottom, in the middle, so they switch. And so when that happens, we do the area from A to B, from where they first intersect to where they intersect again, with the F minus G, because that's the top function minus bottom. Then we switch from B to C, intersection, to other intersection. And now G, which is on the top, minus F on the bottom. Okay. And so that's that. Let's see you guys for Check Your Understanding. Have a great day.